Papa answer.
We will wait a few more minutes for the guests to join.
Respected dignitaries, invited guests, colleagues, and participants. Good morning to you all once again. Welcome to the online FDP on robotics, sponsored by AICTE Training and Learning, ATAL Academy, organized by the Department of EEE, Vidya Academy of Science and Technology. We are in an unprecedented situation and the normal rules no longer apply. We cannot resort to the usual tools in such unusual times. We have a unique opportunity in managing this crisis. Science, technology, and innovation are indispensable for our response to and recovery from this COVID-19 crisis. I believe that by participating in this FDP, we are in the right place at the right time. Together, let us accelerate the exchange of ideas and scaling up of good practices. Let us begin the function with a prayer for seeking the blessings of Almighty. Gajananam Bodhaganaadisevitam Kapitva Jambupara Sarabhakshitam Umasutam Shoga Vinashakaranam Namami Vigneshwara Padapangajam Namami Vigneshwara Padapangajam. Thank you. I invite Dr. Mary P. Verghese, Head of the Department in Charge, Electrical and Electronics Department, with the Academy of Science and Technology, for the welcome address.
Thank you, Ms. Akhila. A warm good morning to one and all, and hearty welcome to the AICTE ATAL funded FDP on robotics, organized by EEE Department of Vidya Academy of Science and Technology, Thrissur. I am here to deliver the formal welcome address. First of all, on behalf of the organizing committee, I express my warm welcome to our chief guest, Dr. Sudhir AP, Assistant Professor, Department of Mechanical Engineering, NIT Calicut. He is an expert in the field of robotics, and we are really grateful to have you, sir, for kindly accepting our invitation. He is also our resource person, and he will be engaging 2 sessions in our FDP. I express my wholehearted welcome to Dr. Sudhir AP. Welcome you, sir. Next, I would like to welcome our Executive Director in his absentia, Engineer G. Mohanachandran, who was always motivating us to organize such events. A warm welcome to you, sir. Our Finance Director, Mr. Suresh Lal, always support us to conduct various programs. A hearty welcome to you, sir. Our Principal, Dr. Saji CB, always encourages us by giving us various suggestions to organize such events. A cordial welcome to you, sir. Next, I would like to welcome our Dean, Dr. Sudha Balagopalan, who always inspired us by her dynamic personality. I extend my esteemed welcome to you, ma'am. Dr. Remini T was our HOD while we applied for this FDP. She has always been a mentor, giving us valuable guidelines for organizing such events. A hearty welcome to you, ma'am. Dr. V.N. Krishnachandran, our Vice Principal, always offered all the support to organize this FDP. I extend my grateful welcome to you, sir. It is an honor and privilege for me to welcome the most important person in any FDP, definitely the participants. On behalf of the organizing committee, I extend a warm welcome to all the distinguished participants to this FDP. Happy learning to you all. I'm really delighted to welcome various HODs and senior staff members to this FDP. An event like this cannot happen overnight. The wheels must start rotating much before. My fellow coordinators, Mr. Pravesh Vivi and Mr. Arun Xavier, Assistant Professors, Department of EEE, has worked a lot to make this FDP happen. A glad welcome to you both. I would like to welcome all my colleagues in EEE department who has been a part and parcel of organizing this event. A hearty welcome to you all. Once again, I give a hearty welcome to the Vidya family members to this event. Once again, wishing you all an enjoyable learning experience. Thank you.
Thank you, ma'am, for your warm words of welcome. And I also welcome you to the function. Next, I invite the president of the function, our principal, Dr. Saji CB, to address you all.
Thank you, Ms. Akhila. Am I audible?
Yes, sir, you are audible.
Yeah, thank you so much. Honorable guest of honor, Dr. Sudhir AP, Department of Mechanical Engineering, NIT Calicut. Our Executive Director, Finance Director, Dean, Vice Principal, Professor Eminiti, our former head of the department and mentor, Professor Mary P. Varghese, Professor Pravesh, heads of various departments, faculty members, delegates from various institutions. Ladies and gentlemen, warm good morning to all of you. In fact, we are very happy to be hosting this faculty development program on robotics funded by the ATAL Academy, New Delhi. All India Council for Technical Education has been always a great support to us in conducting such programs. In fact, after the breakout of the pandemic, Vidya has been conducting many online programs with the support of AICTE. This is one in this series of programs which has been conducted. We started with the program from Master of Computer Applications Department, Applied Science Department, Mechanical Engineering Department, Computer Science Department, and now this is conducted, organized by the Electrical and Electronics Engineering Department. Now, as you're aware, especially as teachers, technology has been moving on a very, on a highly tremendous pace. Today, in fact, if a patient is being saved due to an open heart surgery in a hospital, it is not because of the doctor the patient is being saved. It's not because of the efficiency of the doctor. It is because of the efficiency of the engineer who has developed the robot who is doing the robotic surgery with efficiency. So this means that how good engineers are contributing to the society. And while these engineers are being molded and developed by teachers like each one of you. So this is a great responsibility vested upon all of us in academia. That is why it is always said for teachers as well as for others, learning is lifelong. We need to be keeping in pace with whatever developments are happening, or we should be one step ahead so that we can handhold our students as well as contribute to the technology in terms of the theories and practice, which is the key word, which is essential to meet the developments, the advancements today. It is in this context that we have been arranging series of such faculty development programs, and I'm sure this program on robotics also will be of highly beneficial to each one of the participants by interacting with the experts, as well as sharing your ideas, and at the most importantly, networking with all the participants and the experts so that the knowledge platform of the knowledge gain is being taken forward. My best wishes to each one of you for a fruitful experience in the coming days. Thank you for joining for the program with Vidya. May God bless you. Thank you so much.
Thank you, sir, for those inspiring words. Now, I move on to the formal inauguration of the function. I invite our chief guest, Dr. Sudhir AP, to officially inaugurate our 5-day online FDP.
Hello. Hello.
Yes, sir, you're audible.
Am I audible?
Yes, sir, you're audible.
Good morning, everybody. I'm very happy to be here with you for this faculty development program on robotics. Firstly, I congratulate the coordinators for selecting robotics as the topics. That's a relevant topic for this faculty development program. And due to the shortage of time, I'm not say much about the robotics and all. We'll see in the talk. So without much words, I declare this FTP is open. So I will 9:30 by 9:30 I'll continue the session. Okay, thank you.
Thank you, sir. Now, I invite Engineer G. Mohanachandran, Executive Director, Vidya International Charitable Trust, to felicitate the audience. Sorry, Mohanachandran sir couldn't join us due to some personal issues. So now we move on to the vote of thanks, and I invite Mr. Pravish PV, coordinator of the ATAL FDP, to propose a formal vote of thanks.
Good morning, everyone. Hope I am audible. Okay. I'm here to deliver a formal vote of thanks. First of all, on behalf of the organizing committee, and I express my heartfelt gratitude to Dr. Sudhir AP for accepting our request to be a resource person for the FDP and also inaugurating the FDP. Thank you, sir. We are grateful to Engineer G. Mohanchandran sir, Executive Director of VICT, who readily agreed to attend this program, but due to some personal issues, sir was not able to join. In his absence here, we express our thanks to Mohanchandran sir. My sincere thanks to Mr. Suresh Lal sir, the Finance Director of VICT, who always supports us. We are indebted to our principal, Dr. Saji CB, for all the encouragement offered to us in this regard towards this faculty development program. Thank you, sir. We have been fortunate enough to have two mentors, Dr. Sudha Balagopalan, Dean Academics of the college, and Dr. Remini T, a former HOD of the department. And they were always supporting us in all uh, activities we were conducting at our department. Thank you, ma'am. A big thanks to our Vice Principal, Dr. V. N. Krishnendran, sir, for all the support provided. And we are extremely happy to have a large number of participants from all over the country, and we are grateful to all of you. Thank you all. And this FDP came to life when the proposal was approved by ATAL Academy of AICTE, and we are indebted to the ATAL team for providing the necessary financial supports and all. And I would like to take this opportunity to thank all heads of the departments and senior staff members for all the help offered. And sincere thanks to my coordinators, Dr. Mary P. Varghese, the HOD of the department, and Mr. Arun Xavier. And we are also thankful to the IT department of our college for providing all the necessary technical supports. And heartfelt thanks to all my colleagues of EEE department, and also to all the Vidya family members. Once again, thank you all, and happy learning and happy new year. Thank you.
Thank you, Pravesh. Without much delay, let us move forward to our first session. A warm good morning to all again. Respected resource person of the day, Dr. Sudhir AP, principal, all the external participants, and my dear colleagues. Welcome to the first session of our FDP on robotics. Today we have with us Dr. Sudhir AP to speak on introduction and recent trends in robotics. Dr. AP Sudhir is currently an assistant professor, Mechanical Engineering Department in the National Institute of Technology, Calicut. He is in teaching, research, and academics administration for the last 20 years. He has nearly 70 publications in international and national journals and conferences. He is guiding MTech and PhD students. He has filed for 7 patents in the area of robotics. His research interests are kinematics, dynamics and control of robotics, mobile robotics, and vision systems. He is a member of the Robotics Society India, TRS India, and ISTE. Presently, he is the editor of TRS India. He is a reviewer of various technical journals. He is a member of the Board of Studies in various engineering institutions. It is our honor and privilege to have your presence, sir. Looking forward to hear from you. The session is over to you, sir.
Thank you. Thank you, ma'am, for your introduction. We'll move to the first session. Now I'll share the PPT. Good morning, all. I'm very happy to be here because I saw there are a lot of participants, and mostly due to the mode of transfer of ideas, that is online mode. Now in this session, I'm mainly focusing on the basics of robotics and what are the recent trends in robotics. Then I'll move to the little bit higher level dynamics of robotics. So in the order, when we see the order of the topics, generally it will be the robotics, then we'll start from kinematics, then dynamics. So I think the kinematics and all you're going to see in the next coming days. So without the idea of kinematics. We'll jump to the dynamics after this first part of the talk. So in this, what I'm trying to say is, we will start from very basics. We'll move to the status of research happening now. Then after that, we'll move to the modeling of robotics, that is specifically the dynamic modeling. Okay, see, we all know the basis for the first industrial revolution was the substitution of mechanical energy. You know, till that muscle power was used to operate the machines. Then after the first industrial revolution, the machines came, that is introduced the mechanical power, used prime movers. Then after the first industrial revolution, then the computer, that is during the second industrial revolution, computers came. And after the computers, after introducing the computers, then CNC machines came. So after the first industrial revolutions, NC machine came, that's numerical control machines were introduced. Then CNC machines were introduced, and that CNC machine technology is the basis for the robotics technology. So the technology, when we analyze NC technology, CNC technology, then robotics technology. Now, see, one of the important question comes, what's a robot? Sometimes the people are confused with the term robot. When in my view, you can see when we see the definition of robots, you can see some of the contradictions in the definitions. When we analyze the definitions, there is some contradiction in some of the definitions. But what we can say is the robotics is nothing but a branch of technology which mainly concern about the problems related to the robot design, development, and applications. And we know that robot is not just a machine or it's a mechanical person. It's a special type of, you can say simply in a computer controlled systems, or it's simply a mechatronic system. So what's a robot? What is a robot? Anybody else? Any participants? So you try to interact so that the session will be active, because when we are discussing the theoretical part, mostly it will be, you know, the boring, it will be boring. So you try to interact so that we can make the talk active. So please interact. Anybody else? Can you say what is a robot?
Hello, sir. Good morning, sir.
Yeah, good morning.
Yes, sir. Robot is just a reprogrammable tool. Yeah, machine, sir.
Reprogrammable machine.
Yes, sir. On which we are inserting the program, and according to that, that machine is functioning.
Okay. Okay. Any others? Anybody else? Any other comments? Any other participants? Yes.
Hello.
Yeah. Yeah.
Good morning, sir.
Yeah. Good morning.
Sir, a robot may be an programmable machine that can be reused or used for any defined work.
Okay. Okay. Fine. That is multifunctional. That's what you're
But
saying.
automated machine, sir.
Okay. 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 Then. Okay, we'll see that. There are some definitions, standard definitions. We'll see that. Robot, you know, robot is not a single entity. It's nothing but the assemblage, or it's an integration of various subsystems. When we see the robot, you can see there are some definitions introduced by some of the associations, Robot Institute of America, FIR, IFR, etc., Franchise Association, Korean Association. There are different associations. All these associations, you can see different kinds of definitions. But in that, when we analyze in deep, you can see some of the contradictions. We'll see that. So I will come to the history, then we'll move to the definition. See the robotics is coined from a word, a robota. That's a Czechoslovakian word, which means compulsory service or slave. Okay, it was firstly used in Rossum's Universal Robot around 1921 by Karel Čapek, a Czechoslovakian writer. And then that's a science fiction play written by Karel Čapek. Later it was popularized in Robot, a novel written by Isaac Asimov in 1950. And this term, Isaac Asimov, after introducing this term in his novel Robot, and he has introduced some important laws, that is 3 laws. When we go for designing a robot, generally people look into these 3 laws. First deals with related to human safety. Second law related to robots, slavery of robots, and next is robot survival. So in the first law is the robot may not injure human being. And second law mainly deals with robot must obey orders given by the human without contradicting the first law. So that means the robot must obey orders given by the human without contradicting the first law. And third law mainly deals with the human robot survival. Robot must obey or protect himself or herself without violating the first and second law. So the first law mainly with the human safety. Second, say the robot must obey orders given by the human without violating the first law. And third is a robot must protect its own existence as long as such protection does not conflict the first and second law. So these are the important laws. When we see the definition, and this is what I've asked initially. When we see the definition of robot, you know, the Joseph Ajalberger, he is the father of robotics, a well-known person, experts in industrial robot. And as per his opinion, his statement is like this: I can't define a robot, but I know one when I see one. This is absolutely the right statement. And even though we can see a number of definitions, and this definition or this statement is absolutely right. And see another definition we'll see, robot is an electromechanical. You can see number of definitions like this. Another one definition I'm going to quote here: an electromechanical device with a multiple degrees of freedom that is reprogrammable to accomplish a wide variety of tasks. Very important point is here is wide variety of tasks. It's an electromechanical system and it's a reprogrammable system. So these are important terms in this particular definition. That's what in the audience told it's a reprogrammable. It's wide variety of tasks, that's multifunctional. So we can see this definition. Now, this is what I explained you. I told you initially there are number of associations. That's RIA, Robotics Institute of America, Association of France, that is AFR, then JIRA, IFR, like there are a number of associations, and these are some well-known associations. And Robot Institute of America is again a well-known association. As per the Robot Institute of America definition, an industrial robot is a reprogrammable. Very important term is one is reprogrammable. Next is multifunctional manipulator. So it's very important, is a reprogrammable, multifunctional manipulator designed to move materials, parts, tools, or special devices through variable programmed motions for the performance of wide variety of tasks. So for performing wide variety of tasks, you have to reprogram it. Then you have to, it should be a multifunctional manipulator. We'll see that very important term, reprogram. You know what is reprogrammable system. You know what is multifunctional. Another important term is manipulator. What is manipulator? What is manipulator? Anybody else? Manipulator, robotic manipulator. I think some of you have heard about the robot manipulator. Some of you have, teaching robotics. So what is robot manipulator? Robot manipulator. Am I audible?
Yes, sir, you're audible.
Yeah. So anybody else? Okay, the manipulator.
The participants may unmute yourselves to present answers.
Okay, see here, these are some of the manipulators. And you can see here, this is the base. This is the base. Okay, this is the base. And you have number of links joints. See here, this is joint, this is another joint, this is another joint, like the number of joints up to this part. This is nothing but the end effector. End effector, or we'll call it as, this is the end effector. We'll call it as gripper or end effector. And when we see this particular another manipulator, you can see this another manipulator. You can see here you have a base, you have number of links, rigid body connected through joints. Hello. Then you have, this is the end effector, or we'll call it as gripper or tool. And manipulator means you have to consider the base from base to this up to this point. Not end effector is not included in the manipulator. So you have base, number of links connected through joints up to the wrist. See here, you can, when we see our hand, so you have, this is a shoulder, and you have arms connected through joints, and you have up to the wrist. So you have the hand that is known as the gripper, or we'll call it as the end effector. And this gripper or end effector is not included in the manipulator. So the manipulator means from the base up to shoulder, then arm up to the wrist. So the end effector is not included. Why end effector is not included? Because depending upon our requirement, suppose if you want to do a welding operation, or if you want to pick an object and place it at another place, so pick and place operation, palletizing or assembly, for different operations, we need some different tools or different types of grippers. So depending upon or based on our requirement, you can change this gripper or end effector. So the end effector is not included in the end effector. So manipulator. So manipulator means you have the base, links, arm, etc. up to the wrist. So this end effector is not included in the manipulator. Generally, the people are making mistakes in most of the FTPs and all. When we are going, they are explaining. That's why I specifically asked about the manipulator. The manipulator, in the manipulator, this end effector is not included. Up to the wrist you can take, base up to the wrist. That is the manipulator. So the definition is clear. It's a industrial robot is a programmable, reprogrammable, multifunctional manipulator designed to move parts, material, tools, or special devices for implementing various wide variety of tasks. Now see the robot technology, as I said earlier, in the robot technology, you have, in the technology, initially you have the numerical control technology, that's the NC technology, then computers numerical control, CNC technology, then next is the robot technology. So the basis for the robot technology is the NC technology and then the CNC technology. Now, these are some of the examples for the manipulators. You can see these kind of manipulator. This is one manipulator. So you have the base up to the wrist. This is special type of gripper. Again, this is another type of gripper. This is also another type of gripper. You can see this manipulator. You can see all these manipulator. When we see this manipulator, there is some difference. You can see this base. Base is a closed platform. And again, you have another platform at the top. Okay. Now you have another joint here. You have one joint here. You have another joint here. Like that is connected. So this is known as the parallel manipulator. We'll discuss that. This is another kind of manipulator, robot manipulator. But our discussion is mainly focused on this type of manipulator. This is another kind of manipulator. We'll discuss that. Now, see in the manipulator, as I said, a robot consists of manipulator, end effector, actuator, sensors, controller, processor, software, etc. That means this is what I told you. Robot is not a single entity. It is nothing but the integration of various subsystems. So you have a mechanical structure first, that is mechanism first. If you want to do an operation, you have to design if you want to do design a robot or develop a robot, first step is to design a robot. That means design the mechanism first. Once it is designed, you'll have a mechanical structure, that's mechanism. But after the design, you have to fabricate. Okay, you have fabricated, and that is a robot mechanism. Once it is fabricated, you have to integrate sensors and actuator. When we see the example of our hand, you have muscles and you have joints. So these are the joints. Okay, these are various joints. In the finger itself, you have a number of joints. Okay, so after making the mechanism, after fabricating the mechanism, if you want to drive the mechanism, you have to actuate the links at each and every joint. So this is one joint. If you want to move this, you have to fix an actuator here, right? So in the after the mechanism is ready, you have to fix the actuator at different joints. So this is another joint. If you want to rotate this, you have to fix a actuator here. Actuator may be a different kind that we'll discuss. Now, once it's actuated, you have to check how much it's rotated. Suppose you have a actuator attached this particular joint and you are given power, then it is rotated at a particular angle. But you should know how much angle this link has been rotated. For that, require sensors. How much angle is rotated? For that, you have to fix the sensors. Maybe there are different types of sensors, you know, potentiometers and encoders. There are different position position sensors. You can use any kind of position sensors to identify the position of links. So that is sensors. So now we see here, sensors, actuators. So that is should be connected to the mechanism. Once it's ready, you have to control the mechanism. Control the mechanism. Where is the important point? When we design a mechanism, the mechanism should be kinematically and dynamically stable. Then only you can control the mechanism. And if you want to control the mechanism, you have to design a controller. So system controller you have to design. We'll see. I'll give you a basic idea how to what is a system controller and all. So you have a system controller. And once the controller is ready, you have to calculate. For example, if you want to pick an object from one place and place it on the other location, then you should know where to move and where to place. For that, you need some mathematical calculations by using kinematics. And those calculations are, you can implement those things by using the software. How you can make the software? You should have a kinematic model, mathematical model. So you should have an algorithm. Then after the modeling, you have to write the program based on the mathematical model. Once the model is ready, you program it. You can use any language. then software will be ready. So that is another element of subsystem of robot. And these are the mainly three elements, but you can see one more element in, subsystem in industries, that is known as teach pendant, or without this also you can operate the robot. But if you are having this teach pendant, it's very easy to operate in industries. So teach pendant is just like a box type structure you have seen in overhead cranes in industries. If you are pressing different switches, the mechanism will move, or the lift will move in left, right, up and down by pressing different switches on the box type structure. Similarly, there will be a box type structure and you can press for moving a different fashion of motion of robots. So that's known as teach pendant. So these are the important subsystem of industrial robot, mainly the robot manipulators. See, this is what I told you. When we define, as per that definition, it's focusing only on the manipulator. Other than this manipulator, there are a number of other types of robots. Those definitions, those ideas are not coming into this definition. So this definition only focusing on the manipulators. Okay, so these are the manipulator. You can see base is there, and up to the interpreter, and this is, we'll call it as open mechanism, or we'll say this is serially connected. Okay, this is serially connected, and this serially connected means base is fixed and end effector, the last portion, is open. So we'll call it as, this is an open chain, or we'll call it as open mechanism, or we'll call it as serial mechanism, because these links are serially connected up to the restore and effector. So we'll call it as this open mechanism or serial mechanism. Now, see, I'm trying to give you a most comprehensive classification of robot. That is how to mainly how to classify the robot. And the robot can be classified based on three, because based on three criteria. One is the robot by function. Why I'm explaining this? We are focusing mainly on robot manipulator. Other than this, some of the definition you can see only focusing on manipulator, not to other type of robot. So you should know what are the different types of robots. That's why I'm explaining this. So now you see here, robot by function. The first one is robot manipulator. Robot manipulators, you know what is manipulator? You have the base, then arms, different joints up to the wrist, and effector is not included in the robot manipulator. And the robot manipulator may be a serial, as I said earlier, serially connected, and this will be open. We'll call it as open mechanism, or we'll call it as serial mechanism. Another type is parallel. Parallel in the sense it's a closed mechanism. I'll show you one example. Then that's a parallel mechanism. This is not open. It's closed only. That is parallel mechanism. And next is hybrid type. To integrate these two, serial and parallel, we'll call it as hybrid type of mechanism. So these are different kinds of manipulators. The next is mobile robot. And in the mobile robot may be a wheeled robot. That is, you'll have a wheel, and wheeled robot can be moved through flat terrains. And next is tracked wheels. You know, you have seen in JCB and all tracked kind of wheels. And tracked wheels are, if you are, the robot is having tracked wheels, it can be moved through any kind of terrains. And next is leg robots. You have leg robots, humanoid robots, and 2-leg robot, 4-leg robot, 6-leg robot, 8-leg robot, etc. You can see in the category of leg robots. The next is swimming and underwater robot. That is the water, moving in water. The next is flying robot, that's in air. So all these robots can be categorized another way: land robot, water and underwater robots, or working in water, working in air. So aerial robot, water, underwater or swimming robots, then the land robots. All these robots, you can bring it under three categories: land, water, and working in air. And we see the manipulator, the another category I can say, you have a manipulator, you have the mobile robot. If you're integrating, we'll call it as mobile robotic manipulator. That means you take a robot mobile manipulator, you take this manipulator and place it on the mobile base. Okay, you have a mobile robot, that may be a wheeled or tracked or any kind of robot. Then you place this manipulator above the mobile base. Then we'll call it as mobile manipulator. We'll see that. So you can integrate all these kind of robot. That may be hybrid with mobile, parallel with mobile, serial with mobile, that also with wheel, track, leg. So these combinations, any kind of combination you can make it. That may be for underwater, for cleaning operations, etc. You can fabricate. So as a faculty, whenever you are giving projects to students or you're guiding students, you can focus on these kind of ideas. You can integrate, you can make it hybrid, and you can use for an impact, socially relevant ideas or applications. You can use, you can develop the robot. Now that is one type of category. Another type of category is robot can be classified based on size. Anyway, these robots are coming under this category actually. No, this is another mode of classifying. Robot manipulator may be a macro robot or micro robot or nano robot, or mobile robot may be a macro, micro, or nano, etc. So the based on size, you can call it as macro robots, and macro robots are the robots, and it's measured in meter. That means you can see this is my reach. Actually, when we see the I mean some of the robot, this is the shoulder. If you are standing stationary, if suppose we are stationary, you can move your hand and you can reach maximum at a particular up to some particular area. So that is known as the maximum reach. So the maximum reach is in meters. For example, in our case, our hand is coming about maybe maximum I mean 0.75 meters or maybe 0.5 meters. So that is our maximum reach. So that means the macro robots means dimensions are in meters, then we'll call it as macro robots. And micro robots means the maximum reach is in microns, in terms of microns, or we'll call it as a fraction of millimeters. And nano robot means is the nano level, 10 raised to minus 9 meters, nano levels. Then this is in developing. So you can see there are a lot of simulation research you can see in nanorobots, and some of the nanorobots are already developed and tested in some of the, I mean, rats and all is tested, and it's not tested in, I mean, in full-fledged way in humans. And next is another type of classification is application, based on applications. That is arc welding robot, painting robot, assembly robot, material handling robot, space robot, agriculture robot, surveillance, medical, rehabilitation, entertainment, etc. Depending on what applications, you can classify the robot. You can call it as arc welding robot, agriculture robot, entertainment robot, etc. So these are another classification of robot. Now, when we see, you take any kind of robot, you can bring it under this category. When we see the textbook, you cannot see this kind of classification because that maybe that chapter or that book mainly focusing on this particular kind of robot. So when we take any kind of robot, we can bring it under any of this category. So this is a most comprehensive classification of robot. Now, next we'll see, this already I explained to you, that is manipulators, serial, parallel, hybrid. So this is serial, serially connected, and parallel, you know, this is parallelly, both are connected, closed. Okay, this is not open, and you have an defector. And hybrid means, see, you have this itself parallel. Okay, you have number of links and parallel, upper platform and lower platform. This is parallel robot. This again parallel mechanism. This again parallel mechanism. This is another parallel mechanism. But these parallel mechanisms are serially connected. Okay, open only, but that's why it's known as serial. So parallel mechanisms are serially connected. Then we'll call it this as a hybrid robot. You can see the hybrid approaches for increasing the flexibility and increasing the workspace. Okay, there are some advantages. We'll get advantages of both serial and parallel manipulator if you're going for hybrid mechanisms. So these are all we have discussed already. A parallel mechanism, closed loop mechanism in which end effector is connected to the base at least 2 independent kinematic chains. So now we have 3 independent kinematic chains. At least 2 should be there. Then only you can call it as closed mechanism. And these are the another, you know, these are all, we already discussed. This is a tracked wheel robot. This is a wheel robot. This is a tracked robot, and this wheel robot. You can see this again track. This is sorry. So this is again the track robot. This is tracked wheel, and this is leg robot. Now this is leg and wheel robot. You can see this is what I explained to you. If you are integrating this is a manipulator. Okay, this is a manipulator, and this is the mobile base. Okay, in the above the mobile base, you have fixed a manipulator. But which type of manipulator? You see here, these are closed mechanism. This is parallel, and this is serial. So serial parallel combination you can see here. That's a hybrid robot, and hybrid is fixed above the mobile mechanism. So we'll call it as mobile manipulator and mobile hybrid mechanism. This is a mobile hybrid mechanism in which you have serial manipulator as well as a parallel manipulator. So we can call it as mobile manipulator. And now we can see another robot, that's leg robots. You can see this well-known robot, Asimov robot, Mayo robot, Einstein robot, and HP. Like that, there are a number of robots. You can see humanoid robot. You can see the Einstein robot. You can see the facial expressions of this particular robot. When we analyze the facial expressions, you can see a number of actuators within the head. Maybe 20, I think it's 28 actuators. In some robot, you can see 48 actuators, small actuators. You can see inside the head for making the facial expressions, for creating the facial expressions. You can see gynoid. This is a lady, female robot, female humanoid. We'll call it as gynoid. Gynoid, and male robot will call it as androids. So android robot and gynoids. Gynoid is a lady robot with facial expression. You can see the facial expression, and inside you can see number of actuators. And another classification which I explained earlier is underwater robot, and one aerial robot. This underwater, this is aerial. So these are the classifications. Next is, so why we are going for robot? Hello, participants. So please interact. Why we are going for robot? So you have to interact. Otherwise, I have to call your name and you have to. So please interact. Why you are going for robot?
Good morning, sir.
Yeah, good morning.
Sir, robotics may help to simplify various complicated tasks and to perform various tasks automatically, which may be more precise than the manual tasks.
Yeah, okay, fine. Any others? Any other point to be added? Anybody else?
In case of robots, the personal fatigue applicable to workers may be low, sir.
Yeah, fatigue, you can reduce fatigue, fine.
To make an autonomous system and can able to make decision itself.
Okay, it's on decisions you can, but so human also can take decisions, right?
Yeah.
Yeah. Then next.
Sir, capability to handle a number of tasks at a single time.
Yeah, multiple tasks with multiple and different angle. That's possible, fine. Yes. Okay. See, these are the why use robots? Increase the product quality, superior accuracy, repeatable precision. You know what is precision, accuracy, resolution, etc. You know what are the important categories. We will discuss that. Then now increase efficiency. I'm not going to explain this. You can just go through because these are the simple points. Increase efficiency, because no need of vacation and continuously we can go for without fatigue. Increase safety and reduce cost and reduce manufacturing lead time and increase the productivity. So these are the reason 5 we are going for robots. You can increase the product quality, increase the efficiency, safety, you can reduce the cost, reduce the manufacturing lead time. Ultimately, you have of high profit, you can say. Then now you can see this slide. When we see the slide, we'll get an idea that what is status or statistics of installed robots throughout the world. You can see in 2008 to 2020, you can see the variation or hike in the usage of robots, that is in thousands of units, that is 521 into 1000 units of usage of installed robot in industry in around 1920, I mean up to 20. And this is International Federation of Robotics statistics survey. And you can see when we analyze, the Korea and Japan is taking lead. What is the reason why Japan and Korea are taking lead? What is the reason? See, they have shortage of labor. That's why people are, and also the technology. When we see the technology in India, I'll show you next slide and you'll get the idea. Now you see the slide, you will get an idea where India stands. See, this is the labor cost savings from adoption of advanced technology like robotics. When we save the labor cost, you can see the India position. India position, you can see approximately 0. South Korea, Japan, Canada are leading. This is because shortage of time and shortage of faculty, shortage of laborers and the improved technologies. You will get a clear idea about usage of robots by analyzing this particular figure. Now you should know what is the status of robots in India. India is now emerging a destination for the production of industrial robots. And India accounts for slightly less than 1% of global purchases of industrial robots. And vast variety, around 70% are used in Indian automobile industries. And Indian industries arena is supposed to grow larger in the coming decades and thereby increasing the demand for robotic solutions. That is why we the faculty, has to come up with some ideas and do the research on this and pass the information to the students and motivate the students to come up in this field. That's our responsibility. That's why these kind of faculty development programs helps to add values in education. Now see in how they are used. When we see the industrial robot all over the world, 70% of the robots are using for welding and painting operations. And mainly welding, or you can say industrial operations. Industrial operation means processing operations. And 20% are generally using for pick and place operations and 10% for others. Then research is focused on various aspects of industrial. This focusing only on industrial robotics. That is manipulators, robot manipulators. This mainly focusing on manipulative research, focusing on manipulator control, and difficult design, compliance, dexterity, and visual and effector, feedback, flexible automation, etc. Now, we'll see the classification of robot. And before going to classification, you should know what are the important characteristics of a robot. So can you say what are the important characteristics of robot? Characteristics of robot. What are the important characteristics of robot?
Good morning, sir.
Yeah, good morning.
Sir, it may be one of them may be ability to be programmed, automated, and he may be a perceptive. Whatever instructions maybe are given, that may be a robot may be work accordingly, according to instructions.
Okay, but for implementing all these, what you told, implementing all those kind of operations, what we need actually, we need what? We need higher accuracy, right? We need higher accuracy. So accuracy is one of the important characteristics. Then the repeatability. You know what is accuracy? What is accuracy? What is accuracy? Accuracy of robot, repeatability, resolution, all these are important characteristics. So what is accuracy?
Accuracy is the accuracy is the closeness to the true value, sir.
Yeah. Because if you want to do an operation by the robot has to take pick an object. How closely to that target point? That is accuracy, right? And what about repeatability? Repeatability means the ability of a robot to reach repeatedly at the same point. So that is repeatability. Then what is resolution? Resolution, smallest incremental value that you can control. That is the resolution. That is the smallest incremental value that you can control. That is the resolution. Then you know the precision is nothing but the measurement of repeatability. And another important term, dexterity and non-dexterity. What is dexterity? Because we are not going to discuss that. These are all coming in the area of kinematics. But even though you should know some of the important terms. What is dexterity or non-dexterity?
Sir, good morning, sir.
Yeah, good morning.
Sir, dexterity is working with the both hand.
Pardon?
Working with the both limbs.
Both limbs. So that is not, generally I'm asking, not however this one. Maybe you take a robot. How can you define dexterous workspace or what is workspace, right? We have workspace. So what is dexterity means dexterous workspace. So we'll call it as dexterity and non-dexterity. Okay, your idea is clear, but you are representing you are expressing in another way. Okay, I'll tell you, see, when you take your arm, some of the location, we have workspace. So we have our own workspace. Okay, this is my workspace. And within the workspace, I can move my arm. Okay, move my arm. But when we locate some of the locations, backside, it's very difficult to position or pose. We'll call it as in robot, not only position, orientation also important. So position plus orientation, mathematically, we'll call it as pose. Okay, so we have to represent, not when we suppose center of mass of a fan, we'll call it a XYZ. Okay, suppose when you see the missile, center of mass of the missile, you'll get XYZ coordinate. But orientation also important. When we see the inertial guidance, you see inertial guidance of missiles, you can see the position as well as the orientation. You consider position as well as the orientation. You will suppose this is the moving body. You have the center of mass. You know XYZ with respect to a frame. But what is the orientation? That's also important. So the position of center of mass and the orientation both are important. So both you combinedly will call it as pose of the end effector. So dexterity means in our workspace, for example, when you consider what is the dexterous workspace, suppose if you are able to pose, that means position the orient in my workspace or our workspace, means we'll call it as dexterity. Non-dexterous means in our area, in our workspace, there may be some area where you cannot pose. Sometimes you can position, but you cannot orient. So that area is known as non-dexterity or non-dexterous workspace. So what should be our objective? The mathematical point of view or our design point of view, when you are going to design a robot, our objective is to reduce the non-dexterous workspace. That means you have to get the maximum workspace. So suppose you have a workspace. If you have a non-dexterity or non-dexterous workspace, we'll call it as non-dexterous workspace or non-dexterity is a subset of non-dexterous workspace, is a subset of your workspace. Okay, subset of your workspace. So for getting the maximum workspace, you have to reduce the non-dexterous workspace. That means your arm should reach in all orientations and all poses should reach throughout the workspace. So that means if you are reducing, you make it very, very small, you will get a maximum workspace. Okay, because you have the maximum space. Within the maximum workspace, you can see some of the holes. Holes in the sense you cannot reach, you cannot pose your end effector. So that area is known as the non-dexterous workspace. So when we are designing a robot, one of the important parameter is one of the important things you have to consider, you have to reduce the non-dexterous workspace so that you will get maximum workspace. Okay, that's very important thing you have to consider when you're going for designing a robot. Another thing is singularity. Robot singularity is important. You have to there may be a singular position within the workspace. Singularity means, no, we are not going to discuss mathematically that. You try to understand there is a mathematical, there is a model, we'll call it as a mathematical metric, we'll call it as Jacobian. If the robot Jacobian is determined is equal to 0, then we'll call it as singular positions. And singularity should be, you have to avoid the singularity, or how to avoid, you can minimize the singularity in the operational point of view. Okay, so these are the important things you have to consider when you're going for designing a robot. Now, another point is degeneracy. Degeneracy is another characteristic. Degeneracy means, suppose when we see our arm, our base, we have a foot, that's a base. Then you have different joints, and this is another joint up to your hand. You can rotate like this, but instead of rotating like this, your base or your foot also can be rotated. You make this as stationary and rotating, forgetting this rotation. So this is the excellent position if you are rotating. Forgetting this rotation, either you can rotate this or you can rotate the base. Okay, both are possible. So if you are rotating clockwise and your bottom base foot is rotating anti-clockwise, this will lose 1 degree of freedom, right? That is, you rotate this clockwise and your base is same time with the same speed, your base is rotating anti-clockwise. Finally, you won't get the resultant motion. So that means your degrees of freedom fails, and that is known as degeneracy. I'll show you that what is degeneracy. I'll show you one figure. See, I'll see here. Now you see this figure, this base is rotating and this is also rotating. Suppose this link also you can make exactly vertical, and instead of rotating this in the vertical axis, your base is rotating the vertical axis, you will get the same motion. Suppose this is rotating clockwise exactly in the vertical position and this base is rotating anti-clockwise. So you will lose 1 degree of freedom. Such mechanism is known as, or motion is known as degeneracy motion, or we'll call it degeneracy. Okay, so these are the important characteristics of robot. I have not included in this, but you try to understand accuracy, degeneracy, dexterity, and all some of the important characteristics of robot. Now we'll come to the robot manipulator, classification of robot manipulator. There's a mistake in the spelling. Sorry for that. Now, robot manipulator. When we see the robot manipulator, there are number of classifications of robot manipulator. This classification mainly robot manipulator classification. One is based on the degrees of freedom. First one. Second is based on drive system. And third is based on the control system. And fourth one is based on the mechanical configurations. Now you see here the first one based on degrees of freedom. The based on degrees of freedom. What is degrees of freedom? What is degrees of freedom? Anybody else? What is degrees of freedom? What is degrees of freedom? The degrees of freedom means the number of independent variables that defines motion. As I said earlier, you have this motion. That means it's an independent variable theta that defines the motion. Then that is, suppose you have theta 1 and this is theta 2, second variable that defines the motion. Third, theta 3. And these are all known as the degrees of freedom. So degrees of freedom means it's a independent variable that defines motion. So depending upon the degrees of freedom, you can say 2 degrees of freedom, 3 degrees of freedom, etc. And generally, the mechanism is based on 3 degrees of freedom. And all other additional, for example, 5
Excuse me, sir. Sir, I think there is some network connectivity issue from your end. You are not audible. Sudhir, sir. Participants are requested to stay.
It seems there is some problem in Dr. Sudhir's end. We'll just confirm and we'll respond.
The participants are requested to unmute. Sorry, mute yourself.
We will confirm and tell what's the issue.
Hello? Am I audible?
Yes, sir. Now you're audible.
See, there is some connectivity issue. I think last 2 days there was some issue in the network.
Okay, sir.
There may be a chance to lose the connection. And if it's losing, I'll rejoin. Okay. Okay.
Okay, sir.
Okay. So first is based on degrees of freedom. You know, a number of independent variable defines motion. You can say 2 degrees of freedom, 3 degrees of freedom, etc. You can say. If it is more than 3 degrees of freedom, that degrees of freedom, additional degrees of freedom will be correspond to roll, pitch, shear motions. And next is based on the drive system, that is pneumatic drives, electrical drives, electronic.
Hello, sir. Sir,
Hello?
please share your screen, sir.
Okay, okay.
It is here. Please share your screen, sir.
See, Akila, I see I'm showing host disable the participant screen sharing.
So, 1 second, sir. We'll again make you the co. 1 second.
Yeah.
We will just correct the issue. Participants kindly mute their audio and video. All of the participants.
Sir, your co-host now.
It's okay. It's okay. Now it's visible, right?
Yes, sir. Visible.
Yeah. Okay. Fine. Okay. So second is pneumatic, hydraulic, electrical, electromechanical actuators you can use for the driving the mechanism. So that this we can call it as based on drive system. You can say pneumatic, hydraulic, electrical, actuator based drive systems. Then next classification based on the control system. You can say non-servo control system. Sorry, servo and non-servo. I think some mistakes in this. So the servo and non-servo. Sorry, non-servo and servo control. You know what is servo control and non-servo control? You know, you'll have a feedback and all into servo control systems, and it will be completely automated. And the other one is servo, that is just like your mobile, your remote, you can control manually. So that is the servo and non-servo. Servo control, you have a what I say, the you know, the non-servo, it's the simplest and least expensive type of control system. but it also very limited in flexibility and performance. It can be purely a mechanical system of stops, limit switches and all. You can use it, you can operate. But in the servo control, this is capable of controlling the velocity, acceleration, and path of motion, as well as the endpoints of the path. So you can control any type of things. You can do it with feedback, and it can store complex control programs which can be easily reprogrammed in servo control. Okay, so these are the important points related to servo and non-servo.
Sorry to interrupt you. Can you
Yeah.
please enlarge your screen? Okay, sir. Thank you.
Okay. Okay. So I think servo and non-servo it's clear. In servo, you can control acceleration, velocity, and path of path of motion, etc. In the servo control. But in non-servo, just like simplest type, least expensive type of control system, but it is also having the limited usage, its flexibility and performance. That is the third one. And fourth one is the based on mechanical configuration. That's very important in this one. Based on mechanical configuration, you can define or you can classify the robot. That is, first one is Cartesian robot, cylindrical configuration, cylindrical robot, polar configuration, spherical robot, and joint on configuration. These are the different types of configuration mechanism. When we see any kind of industrial robot, you can bring it under any of these categories. The first is the Cartesian robot. In the Cartesian robot, you can see there are a number of mechanisms. When we see a 3D printer or any kind of mechanism, you can see these kind of motions. And you have X motion like this, Y motion like this, and Z motion like this. That means the end effector will trace a rectangular, this kind of workspace. You can see this is moving down and this is moving in this direction, and then this joint is moving in this direction. So finally you will get a plane. Suppose this is moving like this. In the Cartesian, suppose you have a end effector like this. This is the end effector. This is moving in this fashion. Then this fashion means you will get a line, is it? And suppose this is moving in this fashion, you will get another line. That means if you are moving like this and like this, you will get a plane, right? You will get a plane, horizontal plane. Okay, and that plane is moving exactly at vertical. You will get a solid, right? So that is this kind of motion. So that means this is moving in this direction, moving this direction, you will get a plane, and plane exactly moving in that direction, you will get a solid. So that is rectangular configuration. So that's known as the Cartesian robot. So this end effector will move in 3 linear motion. We'll call it as LLL type, 3 prismatic joint. We'll call it a Cartesian means LLL, or we'll call it as PPP. PPP means prismatic joint. Prismatic joint means you have a reciprocating joint. This is known as the revolute joint. And if you're having a reciprocating motion, the joint is known as prismatic joint. You know, you take a cylinder piston combination, and that joint is the prismatic joint. But when you see the rotating, you can say it's a revolute joint. So you have now here you have prismatic joint. This is prismatic joint, 2-way motion, PP robot. Prismatic, prismatic, prismatic. So you have PPP robot, or we'll call it a linear LLL. Both are same, LLL or PPP type robot. That is known as the Cartesian robot. We'll call it as 3 prismatic joints, LLL or PPP for Cartesian robot. Okay, so this is Z. You see this robot LLL, that is Cartesian type. This one workspace, and this is another mode of representation. Okay, you will get linear, 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 LLL, or we'll call it as prismatic joint, prismatic joint, prismatic. So you will get PPP robot, or PPP LLL type, or we'll call it as 3P robot, 3 prismatic joint. Now next is cylindrical robot. So earlier we got a rectangular volume. Now you will get a cylindrical volume. See how, when will you get a cylinder? You will get a cylinder if you are rotating a plane, right? If you are rotating a plane, how will you get a plane? You will get a plane if you are having a 2 linear motions. One motion, another motion, you will get a plane. Okay. So one motion, that is linear motion, another linear motion, you will get a plane. And that plane, if you are rotating, this is a plane. If you are rotating, you will get a cylinder. So you will get a cylindrical configuration. How will you get a cylindrical configuration? If you are having two prismatic joint and one rotatory joint, you will get a prismatic means two linear and one rotary. Then you will get a cylindrical configuration. You see here, this is linear, this is linear. So you will get a plane. Then that plane you rotate, you will get a cylinder. So the cylindrical robot is a robot which is having the workspace or work volume is cylinder or a part of cylinder. Not complete, may not be a complete cylinder or maybe a part of cylinder. We'll call it as cylindrical robot. So we'll call it as 2PR robot, PPR, that is PP, prismatic, rotation R. So PPR, or we'll call it as 2PR, or we'll call it as LLR, like that. Okay. So then example is, another example is SCARA robot. SCARA is one of the well-known robot. I'll show you. That is selective compliance articulated robot arm. The robotic arm here also will get you are getting a cylindrical configuration. Cylinder, a part of cylinder you are getting. Now next is third is polar configuration. Polar configuration, first was rectangular volume, second one was cylindrical volume, and this is a polar, that is known as a spherical volume, a part of sphere. How will you get a sphere? You will get a sphere if you are rotating. You see here you have a twist. You have a twist. You see here you are rotating like this. And if you are rotating this, if you are rotating, so you have this one, you are having a plane.
I'm writing 1 1. Okay. See, after 1 0 or 1 1, it is a binary number.
See, this is
after binary number.
हमें लगे बिल्कुल भी नहीं लगे
yes,
मैं
ठीक है, तो जैसे आपको पता है कि यहाँ पर कौन सा नंबर डिविजिबल हो सकता है, कौन सा नंबर डिविजिबल.
Okay, so now see here you have a spherical robot. This is spherical, or it's a part of sphere. We'll call it as prismatic or polar configuration. The polar configuration, you have spherical robot. You can see this is a plane. If you rotate, you can see this motion. This is prismatic. This is again revolute or twist. This is also complete revolution. So we'll call it as TRL. TR means twist. Again, twist is nothing but R only, RRL, or we can call it a TRL. You will get as part of sphere. Then those kind of configurations, polar configuration. And most of this kind of robot, you can see you will get a polar configuration. Next is joint arm configuration. Okay, so this is the joint arm configuration, and joint arm configuration is generally we'll call it as again the volume is a sphere only, spherical volume only, but the structure is different, mechanism construction is different. Now you have a base, it's rotating, and you have it's rotating like this, it's rotating like this. You can see here rotation, again rotation, again rotation. Then you will get a spherical volume. We'll call it a joint arm is a combination of cylindrical and articulated configuration. You have a articulated robot. This is known as articulated robot. We'll call it a vertical articulated robot. Then we see here also it's rotating horizontally. Then we'll call it horizontally articulated robot. Horizontally articulated robot is a SCARA robot, and Puma robot is a vertically articulated robot. But here the volume is same. And you can see any kind of this kind of robot. This is known as a Puma robot in most of the industrial applications for welding, painting, and other kind of operation, generally using automobile, or maybe for work cell in assembly operation. You can see this kind of robot. It's a well-known robot that's known as a Puma robot. Now, another important point, see as a faculty, or what are the things we have to consider if you want to design, or sorry, if you want to purchase a robot. Suppose if you want to purchase a robot, what are the parameters you have to consider? Or we'll say these are the important parameters to consider. One is size of the class, degrees of freedom, velocity, drive type, control mode, repeatability, roll pitch here, payload, weight of the robot, joint angle, work volume, etc. These are important parameters to consider when you're going for purchasing a robot. Suppose if you want to purchase a robot, first thing is the degrees of freedom. Second is the payload. Payload in the sense how much load the robot can withstand. 500 kg, 100 kg you can pick. So that's known as a payload. And accuracy, repeatability, these are all very important parameters. Okay, then whether it's a macro robot, micro robot, etc., you should know. Then we will discuss one by one. So if you want to purchase a robot, first is size of class. It's a macro or small or medium or large. You have to say the maximum dimension of the robot work envelope. That's maximum reach. You are in terms of maximum reach, you can say. The next is degrees of freedom. You can see the Puma robot. Puma robot is a 6 degrees of freedom robot. Now, this degrees of freedom, as I explained to you, degrees of freedom you have to say for a particular application, what is the degrees of freedom required. That also should be specified. The next is velocity, whether it's a velocity consideration effect or robotic structure. That is whether it's a cylindrical robot, spherical robot, articulated robot, which you have discussed just now. So that means you have to show you have to tell the mechanical configuration. What should be your work volume, whether it's cylindrical, spherical, articulated, or rectangular. Next is drive type, whether it's a pneumatic, hydraulic, electric, or electro-pneumatic, etc. The next is control mode, whether you have to go for point-to-point mode, control, continuous path control. Point-to-point mode means, you suppose if you want to do a spot welding operations, spot welding in different points, or you can, if you want to move from one point to other, pick up an object from one place and place it in another location. So point to point, one point to another. Suppose if you want to do a continuous operation, that means a welding operation. Welding operation is a continuous operation. If you want to do a continuous operations, you have to go for another mode that is known as continuous path control mode. And next is the lift capacity. That's the payload. Whether payload is up to 5 kg or maybe 20 kg or maybe 40 kg, you have to specify the payload, or 5 kg. Payload should be specified. So these are important. In addition to that, you have to specify accuracy. You have to say resolution, the smallest increment value that you can control, and drive system, as I said earlier, shown here. Then you have to should say repeatability. These are the 3 important other parameters that I missed to include. So that also should be specified in the robot selection. Then these are I'm going to show some of the 2-3 robots which are very much important type of robots. First is a Unimate robot, and first programmable robot designed by George DeWolf, and who coined the term in universal automation. And this robot was initially installed in General Motors and become the first name of the robot company Unimation. And this is a well-known industrial robot introduced, the first robot introduced and used in General Motors, that is Unimate. And this is another milestone, Puma robot. As I said, in the Puma robot I've introduced in Programmed Universal Machine for Assembly that I shown you in the articulated arm. And this is another milestone in robotics. And SCARA robot is another around 1962, which is implemented in industries. So that is SCARA robot, selective compliance arm for robotic assembly. And this is, it's a very important slide. And robot industry entered a phase of rapid growth. Many institutions introduced programs and courses in robotics around 1980. And robotic courses are spread across mechanical, electrical, and computer science department throughout the world. And even though after that, India introduced around 2000 only introduced even in IIT in curriculum. So, but I don't know whether most of now, I think in most of the institutions, universities introduced robotics in the curriculum. That's why this topic is very, very important. And even schools started to introduce some of these small topics in the curriculum about robotics, even in India. So there are a lot of scope in this area to do research and what I say, there are a lot of, in future, there are a lot of scope in this area, and most of the industry is trying for automation of robots. So there are a lot of scope, but there are a lot of problems that to be solved in this area. And this is another emerging, introducing another technology, and that is emerging applications, small robots and micro robots. In the second start a company in the research. In 2003, NASA's Mars Exploration Robot Rover, and 1997 Honda introduced some robot. So these are some of the important milestones in the area of robotics. And what are the important applications of robot? What are the important applications of robot? Mainly, you can see there are, when we analyze the applications, mainly there are two categories. One is material handling operation, and next is tool handling operation. Material handling and tool handling operations. Material handling means loading, unloading machines, assembly operations, palletizing, depalletizing, that is known as the material handling operations. Tool handling operation means you have to use the tool and do some machining operations. So that means or finishing operations or welding operations, drilling, sanding, profiling, grinding, etc. are some machining operations, and finishing operations, you can say, is coating, painting, and cleaning, etc. are examples for finishing operations. And welding operations, that you can condense welding operations, spot welding operations, or different kinds of welding operations you can implement. That's coming under tool handling operations. So mainly two categories: material handling operations, robot application. Robot can be used for material handling operations. Robot can be used for tool handling operations. There are some other specific tasks like assembly, inspection, data collection, medical, space, military, etc. Now see, industrial robot, you can see the material transfer, loading, unloading, spot welding, continuous arc welding, spray coating, assembly, inspection. You can see this is a repeated task you can use because of the fatigue or boring or stressful or labor intensive for human. You can use this kind of robot. These kind of robots are articulated robot. We'll call it a Puma robot for welding operations. This is welding, painting, etc. And this is robots are using for assembly operations. You can see robots are using for assembly operations. This welding robot, and generally in automobile industry you can see this kind of applications. And next is material handling robot is required for packaging. See palletizing. See this is packaging, palletizing, examples of packaging and palletizing. And you can see the work cell. What is work cell and all? Suppose in industries you can see number of work cells. Some may be for paintings or maybe for grinding, drilling, etc. There are different work cells, and robots can be used for present the material for maybe different operations, machine operations. So robot can be used for present the object in the machine work table to do the operations. After completing the operation, a robot itself pick that object and place it in the required locations, maybe in the conveyor, and conveyor will move to the next locations. So loading and unloading work cells, robot can be used. Then firefighting, rescue operations, search operations. You can see the search operations. You can see rescue operations. You can see firefighting operations, etc. You can see the robots are using nowadays for these kind of applications. Then industrial hazardous environment. Sometimes robot cannot, human cannot move and do the operation. So you can see the underwater robot with arm. This is the arm. See, this is another operating atmosphere containing the combustible gases. And you can use this kind of robot in chemical industries, or you can use this robot for hazardous environment, maybe air pollution related, air pollution areas, air polluted areas, for various applications. And you can see the American scientists developed a pioneer response to disaster for in nuclear power stations, and with a large dose of radiations for withstand the loss of radiations. You can see in Baba Atomic Research, BARC and all. There are a lot of research going on in the area of parallel and serial robotics. And these robots are generally, they are developing or developed for these kind of applications. And you can see again hazardous environment, decontaminating the robot, cleaning the main circular pump housing the nuclear power plant. So robot can be used for various applications. I think you have seen a lot of application videos and all.
Sudhir sir.
Yeah.
Yes, sir. I would like to, sorry for interruption. We have 10 minutes to conclude the first session.
Okay. Yeah. I'll do
participants, please note that the attendance link has been sent in the chat box.
Okay, so next, see, this is about the dangerous mines, and you can use robots. And these are the underwater robot for identifying some of the important creatures in underwater areas. And you can see the agriculture. You can see even in agriculture you can use robots. Okay, so the harvesting, all those applications you can use robots. So I'm not going to explain in detail, because while seeing itself you can identify what is the requirement of robot and what is use of robots. And the military applications you can use for military operation is war. Even now in the US, war operations, robots are started to use. You can see number of robots, and these robots we can call it as swarm robotics. Robots can be integrated and communicate with each other and do the operations. Now these are the robots, and generally used for bomb disposals. And these robots is used for bomb disposal, designed to search and locate, neutralize the explosive devices. And this is another biology research by biomimetics robot. You can see 8-legged robot. Then you can see NASA used exploring other planets. They used robots for exploration. Again, exploring the planet, you can see number of robots, either wheel robot, lug robot, different kinds of wheels, omnidirectional wheels, and wheel drug robots, providing the issues of different terrains. If it is a flat terrain, you can go for wheel robot, and if it is lug wheel or lug track combinations, you can avoid. Avoid the problem of different terrains. You can see the kind of robots, how those robots has been designed, and exploring other planets and see a robot in space. You can see this NASA's contribution to space research shuttle. And you can see another important area is surgery. Idea of robot performing open heart surgery sounds like science fiction, but recently the idea has become reality. So now, not recently, and there are a lot of research, work is going on in this area. Even our nearby hospital, you can see this kind of, surgery, robotic based surgery. And again, with the invention of the Invency surgical system introduced 1999 by California company, surgeons can operate patients sitting computer, and you can do the surgery. That is, you'll be in one room, or maybe in the same room. You can operate you'll have a slave robot, and you have the master robot. Okay, the master robot and slave robot, and you can operate the master robot, and slave robot will do the operation based on the signal received from the master robot. So there is another important area, slave master control. Okay, surgical robots are working based on slave and master control, based on servant master control. And before discussing the recent trends, introduction to robotics, we are going to stop the introduction, then we'll go for recent trends, then we'll move to the dynamics, and 1 or 2 slides I'll add in introduction to robotics. And what are the programming methods in robots? And robots can be programmed. For example, if you are having a robot, in guiding, walkthrough, and playback, that's the first method in programming. First method, there are 3 basic classifications. First is guiding, generally using this kind of application in industries. moved manually through intended motion while path is being recorded in the control system. Simple technique that does not require any operator to write program. Relatively short and simple motion, and stored program robot can then play back at different speeds. Actual program. And see this. What is this? See, what you have to do is, suppose you have a robot manipulator, 6 degrees of freedom or 4 degrees of freedom like this. What you have to do is you hold like this, move manually. You just move manually. If you want to do a welding operations through, suppose you have to do a welding operation like this, you just move like this by hand, holding the robot, and you guide by walking through a playback. Then you move this. While moving this, all these intended motions are recorded, or path points are recorded. These are the path points are recorded by the control system, and you can play back. So that is the guiding. That means if you want to do an operations, let it be a welding operations, what you do, your end effector should move through that path, while or design path. And while moving, the path points are recorded. Path points are recorded automatically by the control system, and after that you can play back. That is known as a guiding or playback, or think through or playback. Next is teachment and lead through. So the operator or program can lead the manipulator through the task step by step and recording intended motion. For example, one teach pendant, one motion, one point, you teach it. Another point, you teach it. Another point, you teach it. And number of points, you teach it. Then after teaching all these points, then based on these points, the system will interpolate the other points. For example, you have to move from here to here. So 1 or 2 points you can interpolate by teach pendant. Then which motion and all, maybe a linear or non-linear, this will move by interpolating. Okay, so the only major path points or robots are recorded. Then intermediate points must be interpolated by the control system. Okay, if you want to move like this non-linearly, 2-3 points or major points you can locate, recorded. Then the other points are interpolated by the control system. Okay, then it does not require coding and used for most complex and precise tasks. So this is another kind of programming method, teach pendant. First is walkthrough, and next is the teach pendant. And third mode is the general mode. We'll call it offline programming. So that means it's a high-level language. If you want to do an operation, if you want to do a welding operation or painting operation or any operations, you have to write the program. Okay. Or suppose if you want to develop a robot, you have to design the robot, you have to fabricate. If you want to implement, you have to write the software. You should have a mathematical model, you have to write the software. After that, you have to write the program. How to write for running either any language, C, Python, or any language you can write it. And in industrial robot, they have their own languages introduced by their own companies, its own companies. So they have their own language. But if you are designing a robot, you can design the robot and you can write a code in your own language, maybe C or Python or any kind of language. You can write it and you can run the robot. That's offline language. So these are the main 3 kinds of programming, that is guiding, teach pendant mode, and offline mode. And next is the recent trends in robotics. So far, what we discussed is I tried to give you a basic idea what is robotics, what are different types of robots, what is the classification, what are the characteristics of robot, what are the selection procedures or how to select the robot, and what are the applications of robot, and how to program the robot. So these are the important basic idea I've given in this particular lecture, first part of the lecture. Then maybe 15 minutes we'll go for recent trends in robotics. Then after that, we'll move to the robot dynamics after this session. These are the points I have to tell you. Next, we'll discuss what are the important trends in robotic research or robotics. That we'll discuss after this session. Okay. Thank you. Akhila, anything else to add?
No, sir. I think we can have a question answer session now. So
yeah. If you are having any questions related to this, you can.
You can either unmute yourselves to ask your doubt, or you can use the chat option and I can read out your doubts.
Chat option, you can read out. That's better.
Yes, sir, I'll read it out.
Any questions related to any of the topics related to the basics? I think some of the topics we have explained, maybe it may not be new for some of the participants, but even though they may get some idea about, or they can brush up those ideas. So basic, then we'll move to the research trends. What are the research going on in this area? Okay, if you have any question, you can ask, otherwise we'll stop now. Any questions from participants? Hello? Am I audible?
Maybe they don't have any questions.
Yeah, okay. So these are the fundamentals. They may be knowing also. It's fine because fundamentals things. Anyway, if you have any general question, that also can be welcome. Okay, we'll stop now. We'll continue after. Then
we have a question in the chat box. One minute. It's a question from Purnima Vadak. How should a beginner in this field start? And can she get to know any reference books or something for this?
Yeah. At the end, I'll tell you some of the reference books. Okay, so what you can do is, I think if any faculties in your institute, you just start the work along with them, and or any faculties that you can start like that. Or now I'm going to explain what are the recent research topics. So I'll give you some of the interesting books, and those books you just read it. For beginner and simple books, I'll tell you. And those robotic books you have to refer. After that, you go through the recent research topics. Then you can select some students, you are even BTech or MTech students, and you can give small projects based on the recent research areas. You can also join with them and you have to learn it. So for example, I'm basically from mechanical. But when I was started, so I was not knowing much about electrical, electronics or other stuff. What I did is I joined with them and tried to do work along with them. Then I got some idea like that. I tried to learn, because in robotics, you should have an experience by yourself, by doing. Then only you will get idea. So my request is, if you're interested, you make some basics knowledge in robotics, a modeling method, a control method, all those things. And you then you move to the recent research topics. And from the recent research topics, you select one topic and you read some of the papers. Initially, you won't get it. 2, 3 times, 3, 4 times, you have to read some idea, you will get it. Then you give to your students, and students will read and will do it. But you also to join and you learn it. And also along with that, you try to get guidance from the faculty, maybe from NAT or IIT or some other any good institutions for getting some of the idea or guidance that you. Then like that, if you are really interested, you can learn it.
So we have a response from Ms. Purnima, who said that it was exactly what she wanted to know. But she also has raised another question that since she's from electronics background, is it difficult for her to learn?
Nothing, because I'll tell you, once one of my student, and he was from electrical. He was from electronics, and he credited my course, and he only got S grade. He completed his PhD in robotics, and he has done in his research in snake robots. That is mechanical part of the research was very high, even though he learned well, and he did the research with a high quality. I can say In robotics, there is no departmentalizing. That I'll tell you. In mechanical only will study mechanical or electric, electronic. That if you're doing, you cannot do. So you please try to learn all the topics related to the research. So that's what I have to say. Okay. So you please try to learn the topics associated with your research.
We have one more question from Mr. Praveen. What do you think about the robotization, population of India and unemployment, whether it is contradictory?
No. See, these are the social implications. That's what you're saying. Your social implication of automation. And see, I'll tell you, there are a lot of scope even after implementing automation with robot. But the only problem is the people, those who are not ready to change. Even though I'll tell you the issues, suppose if an industry is going to implement automation with robot or with or without robot, the people are fearing about the employability, the employment issues. They lose the job, etc. But if some people, definitely if you're implementing, there are definitely 50% of people are ready to learn new things. I know. We all know 50% of people will be ready to learn new things. About 25% people will be resistant to learn the things and all. But if you are having some option, there is no other option, they will learn it. But 25%, out of 25%, 10% of people cannot do. So such people may be very senior people and they are not interested. Either they can shift to some other industry. Industry means a small scale or medium scale industry that will be guided or transferred by the parent company itself to other company, because those people expertise is very important, required also some industry. Like that they can shift to some other industries, or they can go for voluntary retirement. That's one option. I think 10% of people will be ready to do that if you're having more offer. And the remaining 17%, again, they can shift to the job to some other industries that can be take care of the parent company itself. So in that way, there won't be any issue of employability or employment issues that can be managed if you're having a better strategy with the employees. I think it may not be an issue of unemployment. That's my opinion. But we have to, company has to give a good training for those 50 or 70%, 75% people, and then they will learn it. But there are some people, they are not ready to learn. Such people, the only thing is some people can go for retirement with all benefits. Or some people can shift to some other company. In that company, these people are very much required. And that will be done by the parent company itself. So these are solutions to solve these kind of issues. I think you're clear.
Yes, sir. And we have one more message from Mr. Praveen to please include research in agricultural robots in the upcoming class.
Okay, fine.
So can we then conclude the session one?
Yeah.
Okay, sir. Thank you so much for that wonderful and informative session, sir. The next session will be starting exactly at 11:30.
Now time is 11:10, right?
Yes, sir.
Okay. Anyway, I'll wind up by 12:30.
Okay, sir.
Okay. So continuously 3 hours will be difficult. I already informed. So 12:30 or maybe, okay, we'll see that. Okay. So we'll start by 11:30, right?
Yes, 11:30.
Yeah. Okay. Thank you.
Thank you, participants.